Today we are going to take a look at this lab on the use of security onion to try to investigate and interpret the HTTP traffic and also the DNS data. So usually when we encounter a typical cybersecurity attack, there are many events that can happen, and different events will generate different data and also different symptoms. So to help us to investigate the event, especially after the attack, we will usually try to store this information or logs onto databases such as MySQL. So the SQL, MySQL is a common database that we use to store the information. Also, it is a very common, very popular target for the hackers, especially they use SQL injection to try and figure out the information inside database. Also later we will try to investigate how the hacker can possibly use the domain name servers or DNS to try to exfiltrate data, meaning how to remove the data and for the hackers use outside the network. So as part of the job of a cybersecurity personnel, we need to analyze the telltale signs of all these exploits. So we will be using the Kibana to try to investigate the information that were exfiltrated during the attack. So for this lab, we will be using the we'll be using the security onion virtual machine. So just now we were trying to test the virtual machine. So please take note for the virtual machine cyber security onion, right? Please use the Oracle VirtualBox. Okay, please use Oracle VirtualBox or do not use the VMware workstation. Okay, so this one take note. Please use Oracle VirtualBox. Do not use your VMware workstation. Okay, because earlier just now about half an hour ago we tried to use a VMware workstation. So apparently the VM do not work properly. So we will use the Oracle VirtualBox to investigate the lab. So let's take a look at the first part of the lab. So for the first part of the lab, we will investigate the SQL injection attack. So what happens is all this information have been stored onto the servers. So all these logs and all the traffic and all the log files have already been stored. So we will use the past data or the log files to try and investigate and also to learn how we can use Kibana to isolate the source of the attack and the information that the attacker is trying to access. So the first part of the lab is we want to make sure that our time frame is determined. So let's log in to the security onion VM. Okay, on my right side, I have already logged into the security onion. Okay, so if you have not started your security onion VM, you can start now. Okay, so after you started the security onion VM, you can go ahead to initiate a terminal session. Okay, so you can initiate a terminal session, and what you will see is something like this. So for the terminal session, this is what you will see. The first thing what we'll do is Okay, the first thing what we'll do is we'll check the status of the security onion. Okay, so let's key in this command sudo show status. Press enter. Your system may ask you to key in the password, and you will see basically something like this. Okay, so if everything goes well, if your security onion is working properly, on your right hand side, you should be able to see the status all okay, green color. If your status is not okay, it will be shown over here lah. So this security onion is actually a package of software. It means if you look at this table over here, so the security onion actually consists of a bunch of software. For example, you have the snot agent. So this is for your IDS. Okay. Basically it's trying to collect all the data. And also we have the Elasticsearch, which is something like your search engine. Okay, for your database. And also Kibana, where you have this for the dashboard or display. So that later on you will see, we can see in the Kibana software, all the data can be displayed very nicely on a bar chart or a line chart or pie chart and so on. So we just make sure that our security onion working properly. All sensors are running fine. Okay, next we are going to do is we're going to use the Kibana on the desktop. So let me just go over to the desktop here and look for Kibana. So let me double click to enter Kibana. So at the beginning, they will give you a warning. Kibana will tell you, sorry, the Chromium browser will tell you your connection is not private. Don't need to worry about this. You just click advance and then click proceed to localhost. Okay. And then after that, they will prompt you to log in to the security onion. So let's key in the username is analyst, and then the password is sidebox. So after a few seconds, Kibana will load. So this is how Kibana looks like. So basically, it is a dashboard or a way to visualize your sensor data. Okay, so inside Kibana, we can actually use many pre-built dashboard visualization. So it's very useful for monitoring and analysis of large group of data. Okay, so on the top right corner now, we are going to toggle the sample time range to last 24 hours. So let's do that. We're already doing last 24 hours over here. Okay, next, we're going to select absolute time range. So let's change the time to include the entire month of June 2020. Okay, so let's change the option absolute. So inside the absolute, we should be able to see this time. So let's select the calendar to toggle to 2020 June. And then for the end date, also to 2020 June. I need to select a start date and then the end date is also June 30th. Okay, so that means we will set our date range between 1st of June to the 30th of June on 2020. Why we want to set the date range to this period? Because later you will see within this period of 30 days, some things happen. There is a series of cyber attack. And then we will use the Kibana to zoom in onto the source and also the telltale signs of where the attack come from, the time zone, the IP address, and whatnot. Okay, once this is done, we click go. And then you will see now the number of logs, instead of 0, it will become this number called 136. And on the right hand side, the line chart, you will see something on the line chart. Okay, so there are some events that are actually happening within this month of June 2020. Okay, so let's go back to the lab sheet. So after this is done, as mentioned, we will see this number of logs 136 and also the line chart. So let's go on to the step 2. So under step 2, we are going to create some filters for the HTTP traffic. So we want to focus on the HTTP traffic. So let's go over and select the Zeek hunting. Okay. So Zeek hunting, you search for HTTP and then you click. So the dashboard will become something like this with two prominent bar chart over here. So as you can see, the bar chart, there are two bar charts shown over here. So the first bar chart is for the destination country. The second bar chart is for the destination port. Okay, so destination country is all United States. The destination port will be port 80. Okay, there are some questions which we will need to ask. We will need to answer inside this lab sheet. Let's take a look. The first question asks, what is the source IP address, as you can see over here? So let's try and take a look whether we can find the source IP address. Okay, so answer is shown over here. So this is your source IP address, 209.165. Dot 165.200.227. So this is a source IP address. The destination IP address of this attack will be 209.165. Dot 200.235. So this is the destination address. Next question, what is the destination port number? Port number will be shown. Yeah, I think the port number is on top. Can you see port number, destination port number is port 80. Okay, so let's write port 80. Okay, let's go down to the next part. So let's take a look at the HTTP logs. So the HTTP logs will show you the results for the first 10 instances. So let's take a look at the logs. Okay, so for the HTTP logs, you can expand individual logs over here. And if you can see carefully, so these are the important things that you can see on the HTTP logs. Over here, the first thing is the timestamp. Okay, so all the events are happening on the June 12, 2020 on the 21 hours 30 minutes. So that means 9:30 p.m. Okay, 9:30 p.m. From this address 200.227 to 200.235 across the HTTP port 80. And then there are some other relevant details over here. Also take note the sensors are triggering like maybe different period. So the first sensor or the last sensor, sorry. The last sensor that we collected the data was 2:30. So most of the attack, as you can see, happens around 21:23. So it's about 9:23 p.m. Around that period. Okay, so that is what we see over here. So the first question they'll ask is let's check the timestamp. What is the timestamp of the first result? So first result is this one over here. So you can simply just actually it's below first result. So let me just change the thing. So first result happens over here. So this is the first timestamp. Copy. I'm not sure I can copy. Okay, never mind. I can't open here, so I have to type it out. So you can actually type it out yourself. June. June 23. Sorry, June 12, 2020. 21:23 p.m. Okay, 21:23, 17 seconds. So this is the timestamp of the first result. Okay, so we can also check the other events. What is the event type? So let's take a look. Event type will be the event type. You can expand this. You click on the button and you can get more information. So in this case, the event type is doc. Okay, DOC doc file. So there's a transmission of a document file. Okay, what is included in the message field? Okay, included in the message field, let's take a look. Okay, there's a lot of info here. So basically, we just try and summarize. Okay, so the message field basically contains the details about the HTTP request. Okay, that we see over here. Also, the HTTP requests. There is a GET request across this address here. Okay, so what is the significance of this information? Why do we find this information significant? Because we know that the request log is trying to initiate a HTTP request over here. Trying to initiate HTTP requests at the web server. Okay. Okay, so now we are done with this. So let's review the results over here. So depending on the information, each level will have a link. Can you see? There will be a link that is connected to individual events. So for example, in this case, this particular event we have over here for June 12, 2020, 9:23 p.m. There's an event here, this link. So you can click on this link and it will open up a web page which will show you the exact information that was captured on the PCAT file. So this is the amount of information that was captured on the security onion. Okay, so if you can see over here, the information actually can be separated by the different colors. The cyan color block on top represents the header. Okay, so this is the header of the HTTP request with the source address, IP destination address, the port numbers, and so on. Also, we can try and determine the OS operating system, the footprints, and also the different links that is coming into the network. Also from here, we can see there's another group of the data, the blue color information. So this blue color information represents the request that was sent by the user. Okay, so the user sent a HTTP request as shown here in blue. So the request is a GET requests to this endpoint multi-day, and the host address is 200.235. The next block here in red represents the response from the HTTP server. So the web server will respond in this case with 200 vectors. Okay, and we can see that the web server is running on this Apache 228 Ubuntu with PHP 5.24, and it is trying to also, this is the cookie of the session. After that, what it reply is this. So this is the content that is trying to reply, the web page with all these HTML relevant stuff over here. Okay, so important thing we take note is we can see that in the log session, if you are alert enough, you should be able to see this information. If you scroll all the way to the bottom, can you see this information over here? Let me try and find it. It's a bit fast, so let me try and find my username. Some more. Oh, that's it. Okay, never mind. In the log session, I think you should be able to see more. So this is the initial text and responses lah. So let me try to go back to the Kibana. Okay, inside the Kibana, you can see the log entry session. There is a part where they will ask for this username and so on. Let me try and see whether I can find it. Box. First. Okay, I think maybe not this one. Let me try and search for another event. Another timestamp. Let's see. Let's try and find another one. I will try and find this one instead. And then we check the data logs. Okay, where is it? Try and find the name. No, it's not here. Okay. So as you can see, maybe I just reoriented you. If you can find this timestamp, then you should be able to find the event. So there's a lot of information inside this whole package. So what we are trying to find is, can you try and find this log entry inside Kibana where you have this timestamp? Okay, can you see? So please look for this timestamp, June 12, 2020, 21:30 hours, 2:30 p.m. Okay, because it seems that only this particular log will show you the clue. Okay, the clue later will show you in a short while, show the information that the attacker is trying to identify, which is actually the credit card details, and also how the attacker will try to exfiltrate the data. That means try to pull out the data and then send it to his own private server and so on. So once you find this event over here, June 12, 2020, 21:30 hours, right? So you can just expand this event, click on the arrow here. So once you expand this event, can you see this ID option? There's one entry called ID. Click on this link. So once you click on this link, you should be able to see the response that is open up in this case. Okay, if you are alert enough, if you're alert enough, and you should be able to see over here this information. Can you see? Maybe you can't see, I just highlight again. So this is the information that we are trying to identify or look out for. Basically, the user is trying to sniff out the user's username. And inside the username entry, it turns out that there's this union operator. Union, if you are not aware, is a operator used in a database table. So what the attacker is trying to do is, the attacker is trying to initiate SQL injection attack, okay, onto this user login page, I think. So user login page, there is a text input for username and password. So using this username and password entry, the hacker managed or is trying to do a SQL injection attack. And then the attacker is trying to sniff out the CCID, the credit card ID, the credit card number. Can you see? The credit card CCV. Okay, CCV is a 3-digit number at the back of your credit card. The credit card expiry date and all the other details like everything from this credit card's database table. So essentially, this is the telltale sign where the hacker is trying to issue or trying to initiate a SQL injection attack at this timestamp here. Okay, 2020 June 12, 9:30 p.m. Okay, from this address. So this is the thing that we are trying to look out for in this Kibana bunch of data. Okay, so let's go back to the left. So as shown over here, we should be able to see the data that is being injected into the user login page. And then after that, right, if you continue to search this whole log file, you can see that your database, on this case, the destination has been compromised, meaning that the attacker successfully exfiltrated, stolen some data from the database. You can try and find it somewhere at the bottom because the reply will be coming from the database or from the web server, sorry. So if you scroll all the way below somewhere around Fine. Just have to be patient. Here, can you see? Let me zoom in. Okay, can you see this information over here? So somewhere within the whole bunch of reply from the destination, the web server actually replied with this information. The username of the credit card user, the credit card user password, signature, and all those things. Can you see? So these are the information that was found. Also, you can see some other details. So in that sense, we notice that the web server has been compromised. That means the database will churn out all the credit card user information, the username, passwords, signature, etc., etc. So that means these are evidences that your database has been compromised or your web server has been compromised. Okay, so that's why you will see something unusual here. So there are some questions you can answer here. So let's try and answer them. What did they say? What do you see later in the transcript regarding username? Okay, the username I think username and passwords. Actually, more than password, username, passwords, and signature are exfiltrated okay, from the web server. Okay, because we see that all this information has been retrieved through the HTTP response. Okay, so give some examples of a username, password, signature, exfiltrated. You can fill in yourself this one. You either have to key in this. Okay, then so basically that's it. We have completed the first part of this lab part 1 on the use of Kibana to try to identify the information, where is it coming from, the stuff that were exfiltrated from the web server and so on. So this is the first part of the lab. Okay, the second part of the lab, let me close this first. I close Kibana. No need close Kibana. I leave it here. Okay, next, the next part of the lab, we are going to continue to use Kibana to try to analyze another possible cybersecurity event. In this case, DNS exfiltration. So what it means is this: sometimes the attacker or the hacker may try to so-called identify information from your DNS server. Especially they may want to know your DNS server IP address so that they can either launch a man-in-the-middle attack or they can spawn another evil twin to try to so-called trick the user into connecting into the wrong DNS server, and then all your particulars are stolen. So we can use Kibana to analyze the events similarly. In this case, to try and find all the suspicious looking DNS queries, and then to try to investigate what exactly happened and so on. So let's go back to the Kibana dashboard, and then we'll reset all the filters, okay? But keep the June 2020 time period. So let's do that now. We'll go all the way to the top, the dashboard, go all the way to the top. Okay, so over here, I'm going to remove all the filter. So I didn't have any filter here, so it's blank, fair enough. So next, we are going over to the part on the DNS exfiltration here. So let's start from this point over here. Your screen should look something like this. If you have set the range June 1st to June 30th, 2020, so you should be able to see the log files. The logs are 22 DNS logs and also the DNS log count over here. Okay. So next, what we are going to do is we are going to zoom in on the DNS related events. Okay, so if you scroll down the Kibana window, you can look for this DNS query types. Okay, so let's go down to the look for your DNS query stuff. Wait, let me see. Did they say? No, okay, never mind. So let's look for the DNS query. So let's go down and look for your DNS related queries. Oh, fine. I think you need to initiate the search query. For this case, DNS, let me click on this DNS zig hunting here. And then, okay, so now after we selected the DNS option under zig hunting, we can see that our event log count for DNS is 22. And then now all my dashboard is focused on the DNS related queries. So as you can see, you can find there's a line chart for DNS log count over time, and also the DNS query class, DNS destination ports, and everything got to do with DNS. Okay, so now let's go and take a look at this DNS client. Okay, so let's look for this item called DNS client and DNS server. So let's go down. So this is our list of DNS clients and servers. Okay, so in our capture, we can identify two main clients. Okay, 192.165.200.235, and the other one is 192.168.0.11. As for the DNS servers, there are 4 DNS servers that were captured. So there is also another chart, if you can see on the right hand side, which supposedly will be able to show you the approximate number of phishing attempts against your DNS server. Okay. So let's continue. So if you scroll further down below, you should be able to see a listing of the DNS queries onto the DNS server. Okay, this is where some of the fishy details come into the picture. If you can see on the left sheet on the left, you notice that there will be some events which are a little bit different. Can you see? So there are some events that are a little bit different compared to the first two over here. Okay, so for example, in this case, the first two over here looks like a normal query, but the second, third, and fourth one looks a little bit long. Okay, so in any case, you may want to take an extra look, investigate further. Why is it that this particular DNS query are a little bit longer than normal? Okay, so let's try and do that now in the Kibana. So if we go back to the top of the window, let's look for the search bar, and then we key in this filter for example.com. So let's go to Kibana, we go all the way to the top and search for this example.com. So after some time, the search bar will initiate the search, and this is the result. So inside your data that you collected, there are 4 DNS queries that are related to this, that contains this request for example, the com. Okay. So let's try to locate the information about the DNS client and the DNS server. So we scroll down. Okay, so for the DNS client, we notice that in this case, the DNS client is 192.168.0.11. So let's note down the client over here on the left sheet. 192.168.0.11. And then you also have the DNS server. So you have the DNS server as well, which is 209.165 point something. Let's check. 200.235. Okay, so these are the details that we have collected from the Kibana over here. Okay, let's try to go in a little bit more detail, and then to look at the unusually long domain name service query to this fictitious website called example.com. So if you scroll the way below, under the DNS query, you should be able to see this. If you select one of the unusually long one, for example, this first one, right, it will open up to show you this. Not sure you can see it. Let me check. Okay, so after that, you should be able to see the files, a CSV file. Okay, let's try and see whether I can download indicator. Okay, so let's try to export raw. Sorry, export raw. This one. So notice that after I exported the file raw, you can see that the DNS query results are exported as a CSV file. So let's try to open up the CSV file using a text editor. Okay, so let's go over here. I use a text editor inside my text editor, gedit. Okay, can you see? You look for this app called gedit, and then we'll try to open up the file which we just downloaded. It's inside the downloads, this file, DNS query. So we double click, and then we'll see that this is the DNS query result that was sent from the Kibana just now. Okay. So over here, you should be able to see this. For the text and save it to the. Okay. One of the possibility is that according to the left sheet, the information may be encoded due to this unusually long string. Okay. So what you can do is we can try to decode this bunch of text inside the CSV file using this SSD command. Okay, let's do that now. So because this command is unusually long, so we are going to use the SSD to try to extract the information. Okay, so let's try to go to downloads. Okay, CD downloads. Then you should be able to see this file that you have just downloaded just now, the CSV file. So let's try to decode the file using the SSD command -r-p DNS queries CSV. Okay, output to this file called secret.txt. Okay. So once you enter, it will decode the file, and you will see that there's another new file that we have just created, which is the decoder file. So let's try and see what is inside this decoder file. Just type cats secret. Okay, so this is the information that was decoded over here. So instead of the extracted this string over here, can you see this whole bunch of stuff, right? After decoding, you will see that it's actually this text that were encoded inside. Okay, so let's answer some of the question. Were the subdomains from DNS query subdomains? If not, what is the texts? No, they are not subdomains. So yeah, I think this is towards the end of the whole lesson. So whole lab, sorry. Let's try to answer this question. Oops. Okay, so were the subdomain from the DNS query? No, they are not. No. They are not subdomains. The text are these are the warning messages. Okay. So what does this result imply about this particular DNS request? What is the larger significance? Let me see. What's the larger significance of it? That means even though the texts or the DNS queries are encrypted, it is possible for the hackers to use SQL. No, not SQL. There's no injection attack. It's possible for the hackers to extract to download the DNS queries and then decode them to see the original data. Okay, so that means in short, even though the domain name queries, the DNS queries are encoded, it is still quite easy for anyone. We can just use a simple Linux command to try to identify what is sent inside the DNS query. In short, this is not secure. Okay. So last question before we close the lab. What may have created this encoded query? And also, what was the DNS selected as means to encrypt the data? What may have created this encoded data? Maybe you can check out the internet. What is the DNS query? What may have created this encoded DNS query? Okay, I'll leave it as an exercise for you all to try. Okay, so we'll try and see whether you can find this answer online. Okay, so I think that's all for this lab.